You guys hear me?
Yep,
Yes,
pretty good now.
yeah. Okay, let's wait for a little bit. I think we have a cup. There are at least one more presentation from an outside contributor. So
Yeah, I just threw them on the agenda for the 26th.
okay, but there is one here which David said he would come and present.
Uh,
Yeah, so the sense I'm getting is because of the distribution spec changes for the OCI artifacts and referrers, there is quite a bit of interest slowly growing around various communities to sort of.
honestly, it was more at KubeCon. I found
Okay.
KubeCon to be a coming out party for OCI artifacts. It was
Okay.
it was quiet before, obviously, but it has gotten big. I presented at ArgoCon.
Uh-huh.
Maybe it'd be helpful, Ram. Would it be interesting for me to present what I talked about then on a future meeting as well?
Okay. Do you want to do that now as a summary or?
It's up to you. I can
Yeah,
do
you can.
both.
Yeah, I guess you could just quickly summarize and then make it a full meeting maybe next time, a full.
Yeah, I basically shared a proposal that I have in the Argo CD community
Yeah.
around adding OCI support for storing and using artifacts um moving forward. And I believe very much that this is the model that it is a good model, is not the only model. Flux is another big Argo GitOps tool already has support for this. So making a lot of alignment between, OCI and Argo is going to be what I'm kind of driving in that community the next little bit.
Yeah, perfect. Sounds good. Hi, David. Thanks for joining.
My pleasure. Thanks for inviting.
Yeah. So the WASM has been let me turn on my yep, let me turn on my camera 1 second. Yeah. Okay. So WASM has been coming up quite a bit in the OCA communities, the distribution spec and the mate spec, right? So, and it is probably one of the, I would say, the early adopters of OCI artifacts. At least people are thinking about that. And this particular working group is all about artifacts in the CNCF community, which means it's more broad. I mean, it's basically broader, all sorts of things, right? Security policies, your SBOMs, your images, various things. So there is interest here, and so there is a bit of an overlap between OCI and CNCF at artifacts level. So yeah, so we would like to hear from you what you have in mind, and that's whatever you put in the agenda. So at least I think you said that someone else was in charge of this, but at least we can get a sense of what the thoughts are in the WASM community.
Certainly. I'm happy to kind of give the background, where we've come from, and how we've gotten to where we are. I'm not sure if I can share, but I'll probably jump into the WASI OCI design and explain that a little bit later. But basically, my group at Microsoft, we started off. My group previously had built something called Cruslet, And Crustlet is a kubelet abstraction for running WebAssembly. This project was moderately successful and gave a really neat path of providing a native way to run WebAssembly on Kubernetes. Kubernetes is the orchestrator that a lot of folks are using. It has a very broad market adoption. WebAssembly would like to work in the spaces where Kubernetes is. So this made sense for that kind of project. What we ended up moving on from Crustlet is over to something called Run WASI. Run WASI started in Deis Labs, where Crustlet lives today. Run WASI, thank you. I am remiss for not adding my name. The Run WASI started in Deis Labs, and the idea was we wanted to move the API down from kubelet, which is very Kubernetes specific, to something further down the stack that made more sense for executing just tasks really. And what we found was the containerd shim API was probably the closest to what we wanted. And this is a pretty simple API. Like the Crustlet API, you could imagine is quite large, or the kubelet API. The containerd shim API is really just like create, start, wait for task, delete task. So this doesn't have a ton of containerisms in it. And this allowed us to go and build tighter abstractions at that level. And if folks are interested, you can see the URI there to Run WASI. And Run WASI gives the basis for teaching containerd how to run WebAssembly modules and components without needing to package up a Docker, an OCI image with the runtime packaged in a OS specific file system and the actual WebAssembly application that you want to execute. So what does that mean? So we can go run WebAssembly today. Like if you have just a vanilla cluster, you can go and say, all right, I'm going to go bake a Linux container image that has, from scratch if you really wanted to, that has like my WebAssembly runtime. So the thing that's going to actually run the WebAssembly, and then your WebAssembly application, and your entry point could be like, say, wasmtime run WebAssembly module, and that gives you a Linux container image that you could then, after you push it, you could then go run in your Kubernetes cluster, and that's all well and good. But if you have, Windows nodes too, you then have to bake a multi-arch image, right? Multi-arc image. That's kind of contrary to what we expect out of WebAssembly. WebAssembly's, it doesn't care about OS. It doesn't care about architecture. It should execute wherever you want to run it. And so we really believe that that's the way it should feel in Kubernetes too. You should get the best of both worlds. You should get the best of WebAssembly, but you should also get the best of Kubernetes too. And when I say best of Kubernetes, I mean your WebAssembly applications should be able to talk to other containers running next to it within its pod, right? You should be able to mount volumes. You should be able to do all the really amazing stuff that we do within Kubernetes, right? Take part in CNI, all this great stuff. So that's why we wanted to extend containerd to then teach it how to run WebAssembly by putting the architecture and OS specific bits within the containerd shim, separating out into some sort of storage artifact, which ended up being an OCI artifact, the WebAssembly bits that we need to run, and teach that containerd shim how to unpack those and do other really cool things like pre-compilation on the node and storing the pre-compiled WebAssembly back in the content store in container D, which is really helpful because it allows you to start up the WebAssembly application so much faster afterwards. So this is the impetus for this, for us, trying to talk to the community, figure out different ways to like how we should structure an OCI or manifest, what layers, like how should this artifact be shaped? And I think was it Brandon also has been quite helpful. So we started up through Tag Runtime WASM Working Group, a subgroup that was working on these OCI artifacts together. In the link in the docs, you can go check out all the notes from the previous meetings. I need to get some videos up on YouTube, but some of the previous videos are up on YouTube under the WASM Working Group Tag Runtime channel. Definitely, I think they're linked in the note there for the meeting. Let's see. So with the artifact, if we want to dig into the artifact structure, would that be interesting to folks? I actually,
Yes.
I'll just open it up to questions if folks are interested.
Yeah. Okay. So, I'm thinking this, the way you've structured this as run WASI is a sibling to something like run C, at least
Yes,
in the
indeed.
Kubernetes world, right? So run C, what it is going to do is it's going to recognize, quote unquote, the artifact to be a container image, and that's why the runtime and that container image match, and therefore you're able to execute it. So in run WASI, what I'm guessing is, quote unquote, this artifact gets matched to, yes, this is a WASM artifact, so therefore I will do whatever needs to be done for WASM. So you do run WASI that artifact, though, and then make it launch.
Not exactly.
Okay.
So we add handlers to the container config and map those to runtime classes in Kubernetes. So we aren't actually inspecting the artifact and deciding, like in the container D, to say, okay, because there's this annotation or other metadata on the artifact itself, go execute this using this handler. That is specified on the pod for the runtime class on the pod itself. And then that directs container D to use a specific handler, the handler being WASM shim.
Got it. Okay, I see. Okay.
However, that would be really cool to add. Like that would be so awesome to start thinking about the problem like that. So like if you could embed into the artifact some kind of metadata that said, hey, hint, I'm this kind, you might want to run me like this, that would be super dope.
Okay, so yeah, so that's so I just wanted to point out this particular issue on image spec that folks have been looking at. So this is how the structure is for at least the way the artifacts is shaping up. So we have runnable container images, is the legacy container image. Then we have non-runnable non-container images, which is things like SBOMs and things like that. They're not runnable, but they are part of the whole idea is to try to collocate all of these things together so that you can address them independently or you can address them through relationships, right? And then there is this runnable non-container images that is where this WASM work is fitting in. So right now the gate, the way you describe it is the gate is in the code somewhere in containerd where which says, hey, look at this artifact, bring up a container as usual, but do something specific to WASM. And therefore then it becomes a part of the Kubernetes ecosystem, the pods and things like that. Then there is this additional wrinkle which says instead of maybe you want to do more in terms of the scope. Maybe it is not just a part of the Kubernetes ecosystem, maybe it is something else. So for example, Kubernetes allows things like managing virtual machines like KubeVirt, right? So it allows you to do that. So maybe there is this orthogonal thing that you could do in the WASM world. Anyway, these are all just questions. So
Yeah, I think those make sense. Yeah, it's convenient to be able to package uh, to package runnable artifacts. How's that?
Yes,
Things that are
yes,
not necessarily container images, do not
yes.
necessarily have an OS or architecture specific binding.
Perfect. Yeah. Okay. That sounds, yeah, that's, I think that universe is opening up with this work. Absolutely. So,
That's fun. Yeah, it's the biggest thing for the highest priority bit for us was to make sure that uh it seems like there's a lot of confusion around artifacts, around
yes.
OCI artifacts, that there's a lot of discussion, and we just want to try to do it in the most community friendly and accessible way possible.
Okay.
um, yeah, I think that's the most challenging part right now is that when stuff's in flux, it's hard to it's hard to deliver stuff.
Uh, okay. So at least the first important step was getting an official release out for both image spec and distribution spec, saying that this support is official in a certain way. Now, after this, I think we can start having conversations on best practices and how to adopt it in our environment. So Brandon, I know you've been working with Brandon. So Brandon is working on a blog article just to summarize all this OCA artifact goodness that should hopefully guide all the efforts that are happening better, hopefully. So let me see if I can find it.
Oh, fantastic.
So let's see. Yeah, yes, this is the article. So this is still a work in progress, and people are reviewing it. So, but at least we can take a look at the latest snapshot of it. So let me add it to that. So this is what his thoughts are on. So this is basically saying what is the official guidelines or the best practices to adopt artifacts in your workflows. So let me put this issue into the notes.
Yes, please.
So yes, I think he's done a pretty good job about this. So the two big things that are the two big changes, if I were to summarize, is so artifacts. When you have a non-runnable whatever, right? It is whatever that is not a container image. Then what you would do is there is a new field called artifact type. You can put whatever you want. So we are giving only a mechanism, not dictating a policy. So you can put whatever artifact you have in here. Of course, if it is rendered under OCI, it will be whatever the naming is. But if it's specific to your organization, then you put whatever you want here, and of course make sure that everybody knows about it. The config section, we make it an empty config. This is a special type of config saying that this is not there is no platform specific information here. So therefore, just so whatever you have here is open to interpretation, and then the rest of the layers is as is. Furthermore, if you want to say that I want to make sure that this particular artifact is related to some other artifacts. An example would be, I have a container image and I am publishing an SBOM that is related to the container image. Then you would make this an artifact. You'll make the artifact type something SBOM JSON, a empty config, and then you will say the subject is the digest of the image that it refers to. And the registries which, so there's implications both on image spec and distribution spec. Image spec, this is the layout. and in the distribution spec, you have new APIs that are able to handle these things. So those are the big ones, right? So that's what I would summarize it. That's how I'd summarize it. And beyond this, it's open to interpretation. I think we should have conversations on, hey, I'm doing this. What do you think in the community? And so then we'll have conversations around this. So, and if you have if you do a reference, the reference will say, give me all the things that refer to this. For example, it could be an image, and then it lists an index with, hey, these are all the things that came up.
So you said something that I think is, I'm not sure if it doesn't jive with my recollection. So the config, the empty config.
Yes.
I think the idea is you only put an empty config in there because it's a mandatory field if you don't actually have some config associated with your artifact.
Yeah, I
That's
think
correct. So,
like for me, I always found it to be confusing. You know, one of the things, especially as we get more, you know, more broad adoption of artifacts, we got to make it simple and easily understood by the community on what all the different recommendations we should have regarding how to actually properly create an artifact. That's something that I think our group here can work on.
correct. Okay. So just to answer Kyle's question specifically, so the config section is built like this mainly because we are very mindful about all the registries being able to move to this in a backward compatible way. That's that's the real reason. So we could have made it far more cleaner, but the problem is then lots of changes have to happen in existing registries and clients. And so this is probably the least, I would say, the path of least resistance to make this happen. Because we do need the OCI registries to get involved in this, because that's where everything is getting stored historically and probably moving forward. If you're not mindful of that, then the change will not happen. It will just become a spec, a document floating in there with no adoption.
The only registry that I've found that has a problem with weird configs is JFrog Artifactory. It has to be a JSON document in there. That's not a spec anywhere. But they're like, I need to parse this as JSON. Gosh darn it! And so they freak out if you give them anything other than that.
That's okay. It's your file. You file an issue and they'll hopefully fix it.
So. They have an issue. Yeah, I filed one with them.
Perfect.
But that my point is that's the only case I've seen that doing whatever you want in the config is not an issue, basically.
Yeah. So I know that Azure's ACR is already moving towards this. Sajay is at least the person I work with. It's since at Microsoft. He's involved with the Azure registry, right? So there are changes happening that this is going to get adopted in Azure, and I think in ECR as well. That's happening. So changes are happening both in the cloud providers, and if you want the on-prem one, of course you can always try Zart or whatever registry you prefer. So
I like Zot just because it's easy, it's scalable, and to be honest, it keeps up with the specification as close as possible.
Yeah, that's what we have been trying to do. Okay, all right. So this is how this is going to work out. So David, I don't know what you want as next steps with regards to this.
So this was mostly just informational. This kind of was spurred on because of SpinCube's application for sandboxing. So Spin is represented as a containerd shim, which is based off of Run WASI, called containerd WASM Spin, I think is the name of the shim. That rhymes way too much. So it's part of this conversation was, hey, what's going on with OCI artifacts in here? Let's educate, let's talk to some of the other working groups around, make sure folks are aware of what's going on, gather feedback if anybody has any interest in getting involved, helping guide these, guide the structure of the manifest, the layer naming, like all the things.
Do you want to talk about that? Like, I think there was interest here to dig one level deeper and look at what does a WASM artifact look like?
100%. If we hop back over to the notes for the meeting, there's a link in the agenda to the WASI OCI design. It's kind of that like chip, pre-read : OCI. The second, yes. Yeah. So this goes through and talks about some of our goals for WASI OCI artifacts. If we want, folks are obviously welcome to read. If you want to jump into the manifest is right below. Then following the manifest is the config block, or a representative config. So you'll see similarly how we've structured the artifact itself. Explanation for the config or the layers.
So is it represented as layers, as in layers on top of one another, like a normal image, or is it different?
So WebAssembly itself can be built as WebAssembly modules, or it can be built as WebAssembly components. Components are intended to be composed together into a single application. So you could imagine that folks would possibly have multiple components included in their application that would perhaps need to be glued together at the end to form the finished application. And then other post-processing could take place on Node to pre-compile or then cache away those bits so that you get faster execution. Each of the runtimes takes a slightly different approach too, which is kind of interesting. So like Spin has some static files that it uses to describe triggers and how those triggers align to different WebAssembly components. So there is possibly the need for static files to be dropped down into the file system. So that would be a layer as well.
So it sounds like based on the comments there, the first one is special in some capacity.
Yes, it is.
It seems to me like it should have a different media type as a result, because it is different.
Perhaps so. I mean, you could also say the same thing about the index 0 of container images, right?
No.
Index 0 does have a special indication for regular file system images, right?
No, they're all tar.gz files, typically, right?
Right.
And you unpack one, and then you unpack the other one on top of it. Then you dealing with whiteout as you go, right? Which is deletions.
Yeah, so I must have missed it. I thought there was an index 0.
You're probably talking about the config blob, David. That's where all the runtime special information is there.
Yeah. So the config contains like a JSON document that says things like, here's the path to your entry point in the file system. Here's the OS, the architecture, environment variables, like all those goodies.
Okay, perhaps I missed it. Gosh, I forgot. I have something sticking in my mind from reading the image spec. Okay, so yes, it could definitely have a different media type.
So, David, am I allowed to make some comments on this document just to guide you along the OCI artifacts path? That's all I would like to do.
Oh yeah, absolutely, please.
Yeah, maybe also Brandon can take a look at this. So Brandon, what he brings to the table is he's going to he's sort of the authority on this, right? He's driving all this effort at the OCI level. So, yeah. So I will drop in a few comments just to tell you how this should be structured as an OCI artifact, and let's take Kyle's comments as well, saying that. Instead of this being it's up to you. It's like I said, this is we cannot dictate policy here. We can only give you a mechanism. So maybe it is an index 0 is something special. That's up to you. Or it could just be another referrer, which means it's a separate artifact that refers to whatever, and then you know what to do with it. So we can give you some options, and you can go do whatever is suitable for you. But I would definitely drop a few comments here, at least from the wearing the OCI hat, if you don't mind.
Yes, of course. Yeah, you know what? It was the array must have the base layer at index 0. That's what it was from layers.
That's fine. That's fine. This works just fine. I mean, if this is how you want to structure it, it's not a problem. So the changes that I would propose are just actually quite cosmetic, if you ask me. So this becomes artifact type outside, and this itself becomes empty config. That's about it. Okay, I'll make a few comments after the meeting carefully. This is good stuff, David. Thanks for bringing it up here.
Really appreciate any feedback you all have, and we'll definitely incorporate it into the design aspects.
Yeah, Brandon is here. Hey, Brandon.
Hey, I'm driving, so I can't do much longer.
Yeah, that's fine. Okay. All right. Okay. Anything else, David, that you would like to talk to us about on this?
Not off the top of my head. If anybody has any questions, please feel free to reach out. And anybody out there that's watching the recording, please drop by the WASM working group. Love to hear from you. And if anybody has any feedback, please don't hesitate. Reach out. You can find us in the CNCF Slack. Thank you.
All right. Thanks, David. Okay, so I'll move on to the next item on this thing. So, so what has happened here is the Kubeflow. Kubeflow is a ML AI ops harness that was initially contributed by Google, and now the community has taken over. And I think Red Hat folks are more involved with this than maybe Google at this point. So what they're doing is they have this whole ML pipeline. There are a lot of experiments that need to be run. There is data to be consumed, data to be emitted, and so on and so forth. And what they were interested in is a place where they can put all this data, and that is why they were interested in this thing called model registry. So the purpose of the model registry is actually a couple of things. One is, of course, you have the workloads, which will consume model data, maybe inference it and things like that. Then they also want the inference data itself somewhere. So somebody pointed this out to me, and I just gave them a presentation on what the OCI artifacts can bring to this community, and they were actually interested. So the outcome of that meeting was there are two parts to this conversation. The first part is there is sort of this inner loop where the data scientists are experimenting in a very tight loop. They're tweaking a lot of parameters, going back and forth. So the data could just directly be on an S3 backend. It could be a PVC with wrapped around an S3. It could be a registry. They don't know about that part as much. There's not a whole lot of clarity there. It could be whatever the data scientists are happy to deal with, right? Then there is an outer loop, which is what they call an outer loop, which is during deployment. So once the data scientists are happy with the quality of the model and the workload itself, then they will publish it somewhere, and that is when the artifacts may be more relevant there, meaning you have the container images that are published, which contain the code that will interpret all the model data and the model data itself. And that is unlikely to change a whole lot at that point. Meanwhile, the inner loop where the scientists are iterating, that could be a much faster loop, right? So this is how they are thinking about this. So the whole the artifacts conversation, both in terms of the artifact and the registry, fits in the so-called outer loop where we are actually ready to deploy. So that's where this
That's a perfect segue into the stuff that I wanted to show, which is a model catalog.
Yeah, and I've been having a lot of conversations regarding the model registry group, because there's within Red Hat, we are working in the upstream community around this, and I've been really promoting the use of OCI artifacts in this community to have them focus on that. I'm not doing it on my day-to-day basis, but I'm kind of working through them to kind of promote that forward.
Do you guys want me to show what I had for the oh, Rom's gone. See if he comes back. All right, well, while he's gone, Andrew, I think you mentioned you were interested in CSI stuff that I was doing in Slack. I think you mentioned something to that effect.
Sorry, lost drop my connection. Okay, I'm back. Sorry, Kyle, you were saying something. I missed that part.
Oh, you cut off. I mean, if you have anything to say, go ahead first.
No, nothing special, right? So, so I guess we could move on to your demo part on how you're.
Yeah, so I can give the overview of what one of the teams I lead, the ACE Data team, has been doing, and then you can tell me where you can ask questions anytime. Tell me where you want to go deeper. There's not enough time to go into like the depth of all of them, but we use OCI everywhere in all of this that we're talking about. So at a high level, we have a okay. At a high level, we have a command line tool. We call it ACE Data Tool, and there's another server associated with it called telemetry, for lack of a better name. But the telemetry, you can think of it as a model catalog and a data set catalog. We don't distinguish models from data sets. We think of them all as data in a graph. And usually a model has a and so the key pieces of this data tool, I'm curious which ones you're interested in looking at. There's different parts of it, but one part is packaging up data sets and models. So we can take a directory that has nested directories and label files and other things associated with it, and author information, where the original sources came from, and so on, descriptions and things like that. Package it all up, shove it into OCI, and then we also tell the telemetry server. So the telemetry server does not run in the registry, right? It runs in our model. I think I alluded to this before. It runs separate. So there's a separate service that just handles the metadata. There's no layers that make it over into the telemetry server. It's just basically the manifest and the config and some other information related to that. And then it has all your library, essentially, right? Your library catalog of all the different pieces of data that you have floating around, all your models and so on, and labels associated with them, and metrics associated with them, and leaderboards that you can build up. You can build up kind of arbitrary leaderboards there, and I can show you that guy. The data tool's job is to push these, we call them bottles, to OCI registries and to pull them down and to manipulate them and change them. And you can deprecate bottles as like Ram was talking about, as people are iterating. Now, not in that super tight loop, right? This is meant for more like the case where I have a good model. This thing is good. I want to package it up and I want to push it because I don't want to lose it. Right? I don't want to risk the possibility of losing it or forgetting how I built it or whatever. But I might come next day, I might come up with a better one. So I might want to deprecate the previous one. And so there's a mechanism to deprecate by pointing at the reference to the prior bottles that you want to deprecate. So that people can easily find the non-deprecated bottles in the catalog. And I guess one aspect of that design is that it supports having your models in many, many registries, right? It's not tied to a single registry. We will have the telemetry server has references to bottles in lots and lots of different registries, and sometimes multiple places in the same registry. And you might have access to some and not others due to network access or due to credentials. And then, so that's the dataset model packaging bullet that I was talking about there. The other aspect of the tool is another subcommand called HDT mirror. And that's for mirroring OCI artifacts, whether it's images or Helm charts or data bottles or whatever, over into another environment over an air gap. So we have 4 commands. One command, it's called gather. You give it a list of images and it builds a index. It copies that, like these images can come from all different places, docker.io, ghcr.io, whatever. You gather them all into your one repo and we build a kind of a Uber index on top of it. So another index gets added. So you might have an index with, if it's a multi-architecture image that you're referencing, would have an index, and then you'd have a manifest is how it would look. And you have, you might put 100 images in that package. We call it a gathered image because you're the process of gathering. And then you can serialize those gathered images to a tar archive. And it's the format of the tar archive is exactly an OCI image layout format. But the order of which we put those blobs in there is very important. We do it all so that it's like depth first, recursive through the graph, so that we also omit blobs that have already been transferred. So it's all incremental. So if the idea is you create one of these tar balls, you put it on a tape, or you put it through a data diode, or you shove it over some single directional communication to some secure environment. Then the next day or the next week or next month, whatever your cadence is, you do it again. And you don't want to copy everything over because you copied terabytes of data the first time. You don't want to do terabytes again if only a couple 100 gigabytes have changed, or maybe 10 gigabytes have changed, that type of thing. So it's careful to make sure it only copies over the layers in the tar file that are missing on the destination side. And then the next step is deserialize, where you take the tar file, convert it, push it back into an OCI repository. And that's basically the gathered image now on the other side, in the other destination repository in the air gap. And then you can scatter that gathered image to any number of registries, wherever you want to locate these things. You can take one image and push it to 5 different places. And so that's what the scatter mechanism does. Often, and all that's done with mounts, if possible, right? So it's usually pretty fast. If you're on the same, if on the same registry, it's crazy fast. If it's not, then it's got to do some copying. So that's the mirroring functionality that we have. I'm not sure if people are interested in hearing about that or not, but that's that part. The next one is Git OCI. So we can take a Git repository, a remote Git repository, and we can package it in such a way that it fits into OCI nicely. And so what I mean by nicely, think about this in light of the mirroring, right? So since we have a very good mirroring tool, it's kind of like, we have a good hammer. Let's see if we can make everything look like a nail, right? That's kind of the idea here. So we have a good way to mirror OCI artifacts. So it's not that easy to actually mirror Git incrementally and PyPy incrementally. Typical state of the art is let's just tar it all up and shove it to a big old disk and hope our disk is 14 terabytes because that's how big PyPy is, right? And copy it over every time and scan it, fire scan it every time, and all the different things you have to do to get through into these sensitive environments. So we don't want to do that. We want to limit the amount of data going over. So the way Git OCI works is we use the lesser known command called git bundle. So git bundle will take you give it a bunch of references and you tell it what references that you already have. You don't need to worry about these. You already have these. and Git bundle will will produce a single file that has all the patches in it, the diffs, such that you can get from where you started from to where you want to get to in the Git graph. And so we construct one of those bundles. We package it all up with associated metadata that's missing from the bundle in a single OCI manifest. And then we push it to OCI. And we also it also supports LFS. So LFS is done kind of like how you'd imagine, right? You would take an LFS object and you just push it as a blob into OCI. The thing that's a kind of a novel thing that we thought about there and that we use is that you don't always want to copy LFS objects over. You might just want to copy the Git data, but maybe you pushed all the LFS stuff into OCI as you were doing it. Well, what we did is we have it so that the LFS, there's two manifests that actually get pushed for Git. One is an LFS manifest, and one is the regular Git commit manifest. So the Git commit manifest has the Git bundles in it as layers, and then the LFS manifest has all of the LFS objects in it as layers. And it has a subject that points to the Git manifest. So it refers to the Git manifest. So we can find the LFS manifest by using the refers API. And that works out pretty well. So that's Git. And then as you now day 2, right? So people make more commits to their Git repo. They add a few more LFS objects, that type of thing. We would the way this works is when you do a Git, an HTTP Git to OCI command, you would end up pushing one more layer. You construct one more Git bundle, assuming there's new commits that you actually want to push, but let's assume that's the case. Then it would create a new Git bundle, add it to the manifest. So instead of having one bundle, now you have two layers essentially in that manifest. And then in the mirroring sense, that first layer didn't change. So it doesn't have to get copied. It's going to get ignored. It'll get skipped. The second layer will get copied over. And so and then on the receiving side, there's the paired command, OCI to Git, that will fetch from OCI and push it into a Git repo. And that does the exact opposite. It does basically the layering, like you would think of as an normal file system in a sense, where it takes one bundle and applies that to the Git repo, and then takes the next bundle and applies that to the Git repo, and so on. And then it caches locally so that it doesn't have to redo all of that every single time. Okay, so that's Git. PyPy is similar. There's 3 commands there. One to go from PyPy to OCI, so you can give it like a Python requirements file, and it'll shove all those packages specified by that requirements file into OCI. And then the reverse, you can go from OCI to PyPy. So you can, after you cross the air gap, you can flip it around. And then you can also serve up PyPy directly from OCI, which I think is the interesting one. So there's a server that's pip compatible and so on. So you can use pip to install packages that are hosted in OCI by way of running a server in front of it. That basically it's an adapter, as you will, between OCI and the Python package index API. So those are the things. I can demo any and all of them. Or I can demo none of it. It's you guys, but
I'm very interested in the Git side of things, because
okay,
as someone who's looking at designing how Argo CD handles OCI content, I see this being potentially an approach, however you're doing it with your tool.
Okay.
To model against. I'm obviously, we're early in the Argo CD side of things, but being able to look at differences between Git revisions over time could be interesting though.
Okay. Yeah, I can show that.
And you said in Slack that you've gotten agreement for the open sourcing of, is it just all these tools or just the CSI?
Of all of them, yeah.
Okay.
Yeah.
Okay, great.
Yeah, I'm sorry I don't have them actually out there yet. There's some debate as to where we want to put them. So I have to kind of wait for some stuff to set up.
Tech guys and gals are having debates? No, I never.
What? That happens? So I guess I didn't mention we call it the CSI bottle driver. It's the container storage interface driver for Kubernetes that mounts bottles into pods, right? So you can, given the digest of a bottle, just the digest, it's all you need. You can give it a full reference to a repository if you want, or you can just give it a digest, because the digest is he's going to go talk to the telemetry server and answer the question. So where is this guy? Once I know the digest, I can go find all the different places it is, and I can go try them until I get it. So you can specify it just by digest, but that's what the CSI bottle driver is all about, is to mount those data sets or models, whatever they might be, into your pods for use for typically inference, right? Could be for training too, I guess. All right. So how much time do we have? We have 9 minutes. Do you want me to share? Want me to share my screen and
Yeah, that'd be great.
go down this path?
Let me unshare. Yeah.
I'm gonna share it this way. Get this out of the way. Okay, so let me see. Oh, you guys are hiding stuff here. Okay, let's see. I have, that's the PyPy stuff. You don't want to see that. You wanted to see some examples of Git. So here's where do I want to start? I think this is a good spot. Nope, I didn't start there. Hang on. I'm gonna find it. Oh yeah, that was me trying to find what tags. So this is my actual repo that the Ace Data Tool repo. There's a couple different repos. This is the main one. I'm just packaging this guy up because it's available. It's here. So and we're gonna push it to Zot. So this is a instance of Zot we have running, and I'm just gonna package it up. So here I'm using, you can use SSH or HTTPS URLs, or file URL. It's just any Git URL here. And we're going to use, it's a Git subcommand, and it's to OCI. So this is going from Git to OCI is what this model is. I'm going to put it in this repo. This is the tag. This is the OCI reference here. And then these are the Git references that you want to push there. So we want the main branch, and I want this particular tag. All right, so I push it, and I get this guy. This is the manifest that's there. Now, I didn't tell it to do LFS. If I want, I'll add that flag in a second here, down here. So HTT also has this OCI tree command, which we found useful to quickly see, like, what does this crazy graph look like? And so for this, the successors, in other words, what's below it, we have this manifest has this config and then one layer, and notice it's media type. This is its media type right here. That's the beginning of its digest. But it's a Git bundle. This Git config is a JSON document that has just some extra bookkeeping information that we needed. We needed references and digests, like SHA-1 digests for the different commits. These two commits, this one and this one. And it has no predecessors in this case. If we add LFS, then we get two manifests pushed. And these are digests of them. You'll notice that the commit manifest digest didn't change. We just added a LFS manifest digest. And we look at the structure of that, you can see that we still have our one Git bundle. It's still the same bundle. That's not where the LFS data is. That's just references to LFS data. And then we have a referrer. So the predecessors of this guy, there's one referrer that shows up, and this is the Git LFS manifest that has a bunch of stuff in it, and I'll show you what that is in a second. And then, so this one is, so I'm fetching the manifest. This is the LFS one. So you'll see that we don't have any config in this one. This is that empty config, but we have a bunch of layers. One of these, it's one per LFS object, essentially. And I forget if we layered these manifests or not. I forget, but we were thinking at one point in time we were going to daisy chain them. So if you had too many LFS references in here, that's no big deal because you can chain them. You can have this guy point to another manifest and so on. But the subject of this is the Git repo manifest. This is the Git commits. So I mean, you can ask questions, correct me if you want me to show you different things or whatever. So this is one bundle. So this bundle is pretty big, right? You can see it's, I guess, what, 11 megabytes or something. If we were to
sorry to interrupt, Kyle.
Yeah,
so in this, right, in this particular case, why is the config media type not empty? It is
because it contains something. So this we have a config for this artifact type, this repo, Git repo guy, and this is what it is. This is why it's not empty. This is what's in there. So you could argue that this should be a layer in my layers, but the problem is this is a special layer. This is not like any of the other layers, right? These layers are going to all be bundles. This one is the config for this artifact.
It's kind of like Helm. We actually throw the Helm chart.yaml in the config object.
Yeah, which I think makes sense.
Yeah, but that is not the guidance from the OCI side, right? So
that's maybe... so you hit the nail on the head, Ram. That's what we have to make sure as a group here to promote and get agreement on, and we should get their input too.
Correct. Yes, and I see this as I see this as a communication issue. Anyway, the dispatch is still pretty new, but I think maybe this is sort of an indication to Brandon to get that blog post out as soon as possible.
I mean, I was looking at that blog post, and I don't know if the language about the empty is clear. There's like an if statement in there. If you have nothing to put there, then it's recommended you put the empty blah. Is kind of how I read it, but maybe I just read it during this meeting, so like
no, that's okay.
I'm not.
That's feedback. Absolutely, it's feedback.
Yeah, if he thinks it needs to say, if he's trying to say something different, then yeah, maybe some clarification of that would be good. So this is what we have in here right now. We have the tags and the heads. They're different things in Git, so we track them differently. But these are just what layer is associated with that guy, who has it, and then this layer is, and then this is the actual SHA-1 Git commit. And what am I showing here? Nothing interesting. As you add more commits, you get, as you do like this to OCI command again, you'll get other layers. And the layers will be considerably smaller, right? This one's 11 megabytes. The next one might be a couple kilobytes if you only have 1 or 2 commits in there, that type of thing. Because Git bundle is very efficient with packing these. These are basically pack files, these bundles with a little bit of extra data in there. What I wonder if I want to see. I was just playing around with it a little bit more, playing around with some other stuff. I don't know if yeah. And then I have some OCI related, like PyPy related stuff here as well. I do that same I play that same game with this is a manifest for no, this is an index, I believe, for PyPy. This is for the there package. Is it right? Yeah, this is for the there package. All the different versions and so on, and I extract the different pieces and parts of them. But it's a tiny package. It's nice to test with because it's super small. But there is there's this public bottle that we just use for testing. It's just the MNIST bottle. But we can poke at this thing too. So as another example to talk about the last point that you guys were just looking at. Man, oh, I need to say fetch, I think. Oh, and I'm going to want to. Hello, come on. Google, what are you doing? Oh, it's going to make me log in. It's not supposed to make me log in. Oh, no such host. Ooh, that's interesting. Did I copy and paste it wrong? Okay, well, maybe that's a bad example. I think I have it over here though. Yeah, so like our bottles look like this. So this is, yeah, see, this is me doing exactly the same thing, and it worked a few minutes ago. So I got something going on with me, I think. So here's the layers for bottles and the config. Again, I have a unique media type here, right, which happens to be the same as the artifact type. And then this is a JSON document that is, I'm not showing it here, but it looks like this. It looks like this. It has labels, it has a description, it has different sources where this bottle came from, its lineage. You can have authors, you can have public artifacts, which are parts of your bottle that you're going to publish to the telemetry server. You can say what bottles this deprecates, and then you have parts, and parts have labels. They have digest, of course, they have size, of course, but they have labels. And the files themselves, I guess I should go back up here. In the case of a bottle, the files themselves are, it depends. We use different formats based on what they are. So like this one is a directory, so he gets tarred up, and then we compressed him because it turns out it was good to compress him. We actually try whether to compress or not and determine whether it's useful. If it's not effective enough, then we don't bother. In this case, this was just a single file, so we compressed him directly and compressed him directly and so on. And we compress them, and we do things differently than they're still to our archives, but we rip out all sorts of things that we don't care about. So in the case of data, we don't care about the owner of the data. It's irrelevant. We want to have cache hits as much as possible. So we get rid of mod time and those kinds of things. They're all reset to 0. So 1970, right? We get rid of the path. So these are all relative paths, not absolute paths. We get rid of time, we get rid of owner and group. They all go to root. They're going to get, when they get mounted, they get turned into the actual user, but for the sake of archiving it, we want it to be as uniform as possible. We handle symlinks and all those kinds of things. And we also handle, file names that are weird. We error out on file names that are not going to work on Windows, so that they know ahead of time versus, oh, I try to pull this bottle on Windows and it doesn't actually work. So we have my point is we use the same game here, where we use the config as something, because we don't want to populate layers. We don't want to pollute layers with something other than, I like the distinction between config being its own thing and layers being pretty much homogeneous. Any other questions? I think we're out of time, so.
Yeah.
Yeah, I was kind of juggling a few things while driving back. Ram, I heard you say a comment about something being not according to the OCI recommendations. What did I miss there?
The config, if it is a OCI image that is not a container image, then this is the case, then you want the config media type to be empty, and your artifact type to be whatever you want it to be.
I think you're still allowed to have a dedicated config, and so if he's got a config there that is for his project, that's acceptable on OCI.
But not as per our it's acceptable because things will consume it, but I don't know if that is the guidance we want to give going forward.
I think when we looked at like the Helm scenario and other ones, we kept the guidance generic enough to include that. And so there's multiple guidance entries depending on whether or not you had your own config or not. And so if you've got your own config, I think this makes sense.
Okay.
And if you don't have your own config, well, then you have to have a config. So you shove in the empty config.
Correct. Correct.
Okay. All right. If that is the case, then it's fine, I guess, this way. But be ready for craziness. This is going to go in different directions without any clear guidelines. But anyway.
Oh, that's the life of OCI.
Yeah.
Everybody does something you don't expect with it. That's the joy of it.
Yeah, the LFS thing that we did, where we had the LFS manifest be refer to the Git manifest, like the Git like commit manifest, was pretty handy. Once we realized we could do that, we were like, ooh, it opens up all sorts of doors. We've used refers before for different things, but it was interesting to think about that kind of data model.
I'm curious, I know we're over time, so if you've got to run, feel free, but I'm curious on the Git example there when you're saying it sounds like you're doing Git mirroring with OCI as an intermediate step in there. And I'm curious what the reasoning was to include OCI as an intermediate step and not just go Git directly to Git and do a Git fetch, Git push, Git merge.
So, okay, yeah. So good question. So that's because of an air gap. So like we don't have access to be able to push. I can clone some repo and I can't push it to some air gap network. I can tar that repo up, or I can put it on some disk somewhere, scan it, make sure it's all approved, and then go plug it into some other system and do a Git push from there. But what I wanted to do is take just the differences from, like, basically construct the Git repo in OCI and make sure that the structure is such that the only thing that changed is minimal, right? I don't want to have like one layer always. I want to have like a layered cake, right? Where I don't change the underlying layers. And that's what this does. So that when I do my mirroring process, when I take stuff from OCI and mirror it across that air gap, I only have to copy the layers that I care about. Does that make sense?
It does. The reason I find it curious is because OCI and Git both kind of follow similar logic in terms of having some kind of Merkle DAG behind the scenes. The data structures are very similar between the both. And so trying to go from Git to OCI almost feels a little bit backwards because it was OCI that was trying to be like Git back in the day.
Yeah, I hear you. Yeah. The big difference between OCI and Git from what you were just saying is the size of the blobs.
Yeah.
And the number of them, right? So
I also think you probably would run into challenges keeping it directly in Git because of the way it's packaging its Merkle tree in there.
Exactly. It makes optimizations because it has so many small things. It makes those optimizations, those pack files and stuff that it repacks when you do Git GC and so on.
And I think the hash that you get is pointing to the top of that whole tree structure in there. And so you're always pointing to the full unpack. You're not pointing to just the diff from the last blob. And so that makes it a little more difficult to do what you're trying to do.
Right. So, and we have this mechanism that mirrors OCI stuff really well. We have to mirror OCI stuff because we want our images over there, but we want our development stuff as well. So we want Git over there. We want PyPy over there because they're building container images over there and trying to do regular work over in some air gapped space, right? It's hard to do work over there, but we're trying to make it better for them.
Got it.
So we're trying to see if we can figure out how to get everything into OCI, like even apt and RPM packages and Alpine, whatever. If we can get those all into OCI, then basically just mirror them into OCI, then having them across the air gap is easier because there's one mechanism.
Apt is a solved problem, right?
Well, so we have apt mirror. We've used app mirror before.
So that has already been done in OCI. Akihiro did work on that one a while back. So you can point Debian package repo to an OCI repository, and it'll pull directly from OCI.
Exactly. Yeah. So we don't want to put that in here because it's already been done.
Yeah.
Yeah. Yeah. We haven't looked at using that one yet. I've looked at using it not in the air gap sense, but not with the air gapped idea yet.
Yeah. I imagine since it's an OCI, you'd just be able to mirror it across and then point whatever is in the correct app to mirror.
Right. Exactly. And once you get into OCI, it's easy.
Yep. Well, the fact that Akihiro already did the work to make the package and apt and all that stuff point to an OCI repository instead of a strict Debian repository was very interesting.
Yeah. It's not it's not very publicized. Yes, I'm aware of that work, Brandon, but surprisingly, it is not very publicized. Maybe it is time to bubble that up.
I think that would be a question for Akihiro because it's his name on all that work.
Yeah, I guess.
I don't want to send him a bunch of bug reports if he's like, wait, that was just my little personal side project.
That's correct. Yes. Yeah. I got the sense that it was mostly a side project, but yes, you're right.
Yeah.
A lot of the work has been done there.
Yeah, he's done a bunch. I think when you look at Debian, they've got multiple transports, and so you have to normally add a transport for HTTPS, and I think he has added a new transport for OCI, and suddenly all the packages come across that way.
I know a couple of distributions that are already moved to OCI. For example, the Brew, on Mac OS, right? The Brew, they are publishing their images as OCI. And I know about some other distros like Alt Linux and things like that. I came to know about. They are also looking at OCI to publish their images, their repo images, right? So there is a precedent on doing distro artifacts using OCI.
Yeah, the strange. So we have a project. We call it Hops. That is working on. Basically, we're writing a Go program to do the install of bottles from Homebrew. You taking advantage of the fact that they use GHCR.io to store their bottles, and they use the bottle, like this is the Homebrew bottle we're talking about now, not my version, not my data bottle thing. And Homebrew is interesting in that those artifacts are not self-contained, unfortunately. They're almost self-contained, but they're not. An individual bottle does not contain all the information necessary to install said bottle. You need another file from another source.
Correct. You need an
non-OCI to go install it.
You need it. Yeah, you're right. You need an installer. So they have used it mainly as a substrate to park stuff, but you still need an external installer to actually unpack it in a very same way. Yes. So those are not really runnable images directly.
Right. And it's interesting. They don't think about the backend as OCI. They're using OCI, but the URLs that they store are to the /blob endpoint. Like they're curling the actual blobs down because it's unauthenticated. There's no issues with any of that. So they're literally just curling the blobs down is how they're getting data from the OCI registry. They're not using an OCI client of any sort, which is fine. I mean, it's a REST API, but I just think it's interesting. They're not using the manifest. That their link is to the blob.
It's all fun and games till someone turns auth on.
Exactly. And then it doesn't work
anymore. All right. I think yeah, we have 15 minutes over. So we can have this follow-on conversation in the next meeting or in our Slack channel. This is actually pretty neat work. I would like to get my hands on this. A proxy, a PyPy proxy in front of OCI, Git proxy in front of OCI, things like that. So
yeah, I think I think the transport idea would be fun to have. Like so Git actually has the ability to do the transport idea as well. So you can imagine having a Git push that just pushes to OCI. I think that's possible. We're not 100% sure, but I think that's possible. And the reverse, the fetch, those parts are pluggable in Git. And then in Python, like for pip install, I suspect they're pluggable as well. So it's possible that a transport could be built there to say you're going to actually go talk to OCI instead of PyPy index. I don't know.
Okay, good stuff. This is all good stuff. This is all client side. By the way, Brandon, I would have categorized all of this work as client side requirements. So
yeah,
I feel like I'm getting called out there.
All right, see you guys.
All right, thanks, Kev. Thanks, Brandon. Bye.
Thanks. Have a great weekend.